Hello, Year 10. I hope to find you well. We are going to be starting a new topic this week. Apologies for those of you who aren't getting to see me because I'm currently working on Tuesdays in school, and I know the vast majority of you are in schools on Wednesday. So I thought you'd appreciate a little video with me in for a change. So the topic of vectors, yes, you've seen from that starter activity, we have met, albeit in a very quick way, vectors before with translations, where we've represented the movement of one shape to another place as a translation vector. What we're going to be doing today is we are going to be looking at a visual way of representing what we're going to call a column vector, but you can very much think of it as the same thing as a translation vector. A column vector as a diagram and interchanging between a diagram and a column vector. And just for something a little bit more interesting, we are going to look at how you find the magnitude of a column vector. So I hope you've managed to print out the sheet. If you've not been able to print out the sheet, then please just write this into your book under the title and objective. So, as we've quickly mentioned already, we have met vectors in the topic of transformations where we used something called a translation vector to represent the movement between a shape from one location to another location. Now, a vector is a quantity that has size, which is sometimes referred to as magnitude. And we use the word magnitude when we're describing earthquakes and how big an earthquake is. So that's a nice way of remembering that magnitude refers to the size. But a vector also has direction. Now, you might have done a little bit of work on vector quantities and scalar quantities in science. So a vector quantity has magnitude and direction, whereas scalar quantity only has size. And perhaps if I'm giving you an example of a difference, a scalar quantity could be speed, whereas the vector equivalent, so the vector quantity, would be velocity. Okay, we have seen this notation before when we did our translation vectors, and this is what I'm now going to call a column vector. And it has two numbers, very much like a coordinate. And you might recall from last year that the first number represents movement left and right. And the easiest way to remember in terms of positive and negatives is think about a set of axes. The positive numbers along the x-axis are that way, the negative numbers are in that direction. And the second number represents the y-axis. Okay? And similarly, a positive number on the y-axis goes up and a negative number goes down. So, bearing that in mind, 3 negative 4 means 3 places to the right and negative 4 going down, so it means 4 down. So, how do I represent this as a diagram? Well, you pick a starting point on the grid and you then show what 3 to the right, 4 down looks like. So you need to use a little bit of common sense as to where you pick your point. So I'm going to pick there. I'm going to do it in pen, but you should probably do this in pencil. I'm going to go 3 to the right from my starting point and 4 down. And I then just join that up with a ruler. I then actually have to add one more thing to finish it off, and that is an arrow showing the direction. Okay, and we normally place the arrow in the middle of the line, a little bit like if you were doing parallel lines. Okay, the reason why we have to put an arrow in, if I just put a line by itself, we might not know, am I going this direction or am I going in the exact opposite direction? Right, let's look at this second one. So similarly, we've got -1, which means 1 to the left, and positive 5 is going to be 5 up. So, again, pick a sensible place to begin. So I've got room to do 5 up, so I'm going 1 to the left, 5 up. And again, I'm going to join that with my ruler. So the arrow shows the direction, and the length of the line is representing the magnitude, so how big it is. So we've looked how we can go from a column vector to the diagram, but of course we could be asked to do it the other way around. And I'm sure the vast majority of you will now be able to do these 3 questions by yourself. So what I suggest you do is you just pause the video here and have a go at writing these using column vectors, and then I will go through the solutions. Okay, so I'm going to show you a little bit of notation, so you might just need to add a little bit more to yours. Okay, I'm going to call this vector A, and I can see with the direction of the arrow that A is going 3 to the right, so that is 3, and 2 up, which is 2. So vector A is 3, 2. So here's one type of notation already. If I write a single letter to represent a vector, I underline it, and then I can write my column vector next to it. Now you will see something different in a book or on your exam, because in a book or on an exam they will do this using the bold font face. We can't do that when we're using a pen, so we underline it instead. Okay. That's just one type of notation. Let me show you a notation that you saw in the starter. Suppose I give my vector a name using 2 lines, a little bit like a line segment. This vector goes from C to D, so I can write C to D with an arrow along it. And if we count this vector, it's 3 to the left, so that is negative 3. And 3 up, so that is positive 3. I'll go back to my single letter notation for this one. I'm working out vector B here, 2 to the right, positive 2, 4 down, negative 4. So that is how we can go from the diagram to the vector. So the final skill I am interested in for today's first lesson is looking at how we can work out the magnitude of a vector. Okay, now I'm going to call this vector A. Now there is a new type of notation that you could potentially see, which talks about the magnitude of something, okay? And the magnitude can also be called the modulus. And the way that I write modulus is I just put the vector in 2 straight lines, okay? Certainly this notation is used a lot more at A level, okay? So if I want to work out the length of the line, I'm going to be using Pythagoras' theorem. So you might be thinking, well, why does Pythagoras' theorem work? Well, if you think about it, a vector is broken already into a horizontal movement and a vertical movement. And if I draw in that horizontal movement and that vertical movement, we end up with a right-angled triangle. And we know we can find the length of the hypotenuse using Pythagoras' theorem. Okay, so this length is 3. This length is 2. We don't know what it's measured in, so I will just refer to that as 3 units and 2 units. Now, if I want to work out the length of this, I need to do 3 squared plus 2 squared and then square root my answer. So 3 squared is 9, 2 squared is 4, so this becomes the square root of 13, and I'm going to leave that as a third root 13 units. Okay, so please go back to my instructions. It'll tell you what to do next. Hope you've enjoyed the video, and that is me signing off for the time being. Goodbye.